What's up everybody, and welcome back to another Flow video. I just recorded a 30-minute video on multi-signing, and I just realized that it might be a lot more helpful if I included a diagram at the beginning. And also, I forgot to mention in the video that all of what you're seeing in the upcoming video is so thanks to Max. So Max is a wonderful Flow developer in the Flow ecosystem. He's on the Flow team and is so incredibly helpful with everyone on Flow, especially in the JavaScript world. So huge thank you to Max for helping me learn about this type of content and inspiring me to help others. So everything that I'm going to go over in this video, you can check out github.com/maxstalker/flow multi-part sign process. And Max has done this is a really helpful GitHub repo that's helped a lot of people. So if at the end of this video you're still confused with what I showed you, check out this repo where Max walks through a pretty in-depth example of how to do multi-signing. So definitely wanted to say that. Now the second thing is I'm going to go over a quick diagram of what you're going to see in the next parts of the video. So if you want to jump into multi-signing and what I did first, skip this part of the video, and then if you're confused, come back to this. But this is going to be basically a description of what we're even doing. So multi-signing is essentially where you want multiple people to sign a transaction. Now, in essence, I'm going to break it down pretty simply right now. In essence, that means you need access to two people's private keys somehow. And you need to be able to have multiple people using the private keys to sign a transaction. Now, as you've probably guessed, on your front end, you only have like a user, right? So we're going to type in user here. So you only have a user and access to their, basically like authorization, because when they log in through Blocto, you can send a transaction on behalf of the user using fcl.auths, which is the user's authorization function, and you'll see that in the video. But the question is, well, how do we get a signature from the admin? Well, what's going to happen is on your front end, you'll have the user, right? And so then you're going to have like a long transaction here. Let's make this let's make these different colors so that it's not as confusing, right? So let's just make this like, I don't know. Let's just make these that color, and let's just make the transaction green for flow. I don't know. So this is going to be your transaction. Now, your transaction is going to need access to, if you have multiple authorizers or multiple signers, you're going to need access to both the user and the admin signer. So the user, I'm going to name this user signer. This is, So the user, I guess I can't change it. User signer. So the user signer is pretty easy because we're going to be using fcl.auths in order to do that. But the problem is getting the admin's signature. How do we get access to the admin signature if we're just a user on the front end? That's where this video is going to really focus on. And so if we draw another box here, let's make this a different color, so like black. And let's go in here and type in admin signature. This is going to be done using a post request to the backend. So let's do a little drawing here. A post request to the backend. So this is going to be a post. And that post request is going to basically take in the signable message from the front end and sign it with the admin's private key that is stored on the back end. And then what it's going to do after that is return the signed message back here, right? So this is going to return the signed, or return the signature back to the front end. And then what's going to happen is when the transaction executes, both of these things, so let's do these arrows, both the user's fcl.auths and the admin signature will be available to the transaction. So this is sort of a diagram to help you understand exactly what's going on. And one question you may have right now is like, well, in this scenario, if we can just make a post request to the backend, then can't we just get the admin signature whenever we want? And isn't that like really bad? The answer is yes. And we're going to go over in the next video how to stop that. But anyway, I know I'm rambling. This is a diagram to help you understand what's going on in this example. Awesome. So go watch the video, and if you have questions, come back to this diagram or continue watching, and or watch the previous two videos as well, because those help as well. All right, good luck with the video. What is up, everybody? It is Jacob back at it again for another Flow video. I just broke my chair. And in this video, we're going to be talking about how to multi-sign transactions. So what does that even mean? Well, I'm going to spend the first 5 minutes in this video talking about the things that I've showed so far, which is single signer transactions. And then I'm going to explain why you might want a multi-sign transaction. So if you already know about multi-sign transactions, you might want to skip the first couple minutes of this video, but I'm going to be explaining what I even mean by this, because a lot of people don't understand what multi-sign really means and how it can be helpful in your application. So to start off this video, well, first of all, look at the Northwestern rep I have going on. We just got beat in a basketball game, my university's basketball team, in a stunning defeat. So I'm a bit depressed, but we're back at it again for a flow video. So anyway, let me sort of explain the structure of this this little repo I have here. This front end is essentially a create React app, like boilerplate. The only things that I've done is I've installed onFlow FCL and onFlow types, and I've also configured FCL to testnet. That's really all I did, and I deleted like the base stuff, like the logo and all that. So I'm assuming that those of you that are watching this video already have a front end and back end set up, which is why I didn't waste time sort of setting that up in this video. And then, so that's my front end. And then my server, I actually used the back end we've been using in the previous two videos where I taught you how to add keys and sign a transaction on a back end. The only changes I made were I got rid of the the transaction that we were running in here, because we're going to be running the transaction on the front end. And all I've done is I've set up a very simple Express server. So it required Express, body parser, cores, all the normal stuff. Spun up my Express server and just did the base default stuff, so that when I run node main.js, it's going to spin up a server so that we can make posts and get requests to it. And then you'll notice that in the helpers folder here, if you watched the previous two videos, we had the sign function, we had the hash function, and we also had the authorization function. But in this video, I deleted that authorization function because that's going to be on the front end. So anyway, this is just the setup I have going on. If you don't really understand what I just said, just know that all I have is a front end and back end setup. The back end is just a server folder here, and it's just basically boilerplate code to work with Flow, right? So that's really all there is. Okay, so what do I mean by multi-sign transaction? Well, let's go to app.js and let's spin up like a single signer transaction really quick. So I've already implemented this stuff here. So let's go ahead and just start doing some base like flow stuff that you would do in your React project. So let's store the user that's logged in through Blocto. So let's just imagine we're in a scenario where we just want a user that's logged in through Blocto to be the payer, the proposer, and the authorizer in a transaction, right? So pretty simple stuff. So let's add a button in here called login. And this is just simply going to be, on click equals, and this, again, this is all just like boilerplate stuff really for your Flow app, but, FCL.authenticate. Let's also add a logout button, FCL.unauthenticate. Let's go ahead and just wrap these two in a div, because I have some base styling that this will look good in, and that should be good to go. And then the next thing I can do is I can just say like, let's add like an H1 tag here, and let's say if the user is not nil and user.address, then just display user.adr, otherwise display not logged in. So pretty simple stuff, right? And so let's just close that there. Now if I in my terminal, I have my server right here and my front end right here. I'm actually gonna switch these two because I usually like my whatever. So this is my front end folder. So if I just run npm start here, it's going to launch my React application, and we should see some very simple stuff here, so we can log in and log out, right? So boom, it launches the web page, and it should load pretty soon. So of course there's an error here. So use state is not defined. Okay, and that is because we have to import use state, and we're also going to use effect from React. Cool. And one other thing we're going to add here is, we're going to use effect here. I do this in all my React apps where, right when the page loads, you want to do fcl.current_user .subscribe set user. And what this is going to do is just make it so that when you refresh your web page, the user is going to stay logged in. So if we go to our web page here and refresh the page, it says not logged in. But if we click on login and we confirm, now we're logged in with this account, right? So this is very boilerplate stuff. Now, one other thing we're going to add before we actually dive into this example is if we go down here and let's just add a button. Let's just add a button called like run single sign transaction. Let's make an on-click handler here. That's just going to be called single sign. All right, and let's make a function called single sign. So const single sign equals the normal stuff, and this is just going to be an FCL or let. I'll just say const transaction ID equals await FCL dot send FCL dot transaction, and this is just going to be some very basic stuff. So transaction like that. Prepare. This is going to be a signer, which is the auth account. And then that's all we're going to put inside for the transaction. So nothing really going on. And then this is the important part. So we say FCL.payer. And, in your normal React app, if we're doing this on behalf of the person that's logged in through Blocto, you use the FCL.auth authorization function. So let's also do FCL.proposer. That's FCL.auth as well. Then the last thing is FCL.authorizations. And that's going to be an array of authorizations, which in this case is just one. And the last thing is going to be FCL.limit, which is 999. Whatever. And then we're just going to say then FCL.decode. We're going to then say console.log the transaction ID. Okay, cool. So when we run this function, this is just single sign. And what that means is that there's only one person signing this transaction. So, the person that's logged in through Blocto, that's the FCL.auths here. So we're using the person that's logged in through Blocto for the payer, the proposer, and the authorization. So it's pretty basic stuff. And so if we actually go to our webpage here, let's go to our console up top. I have to make this async. So let's make sure this is async so that we can await. Go back. And now when let's refresh the page here. So why is this not button? Did I do something? Oh, because I made it a div. So if I make it a button, let's refresh the page. And here, so run single sign transaction. So when I click this button, it's going to come up with the, Blocto prompt here. And if I click approve, then it's going to log the transaction ID here. And we can actually go and view this on testnet.flowscan.org, copy and paste in our address or the transaction ID and see that it went through, right? So where multi-sign comes in is sometimes what you want to do is you want to have the user that's logged in through Blocto on the front end, you want to have that person propose the transaction, but you want to have the admin on your back end authorize or pay for the transaction. And maybe reasons for this are, for example, if you have a pack opening in your NFT project and you don't want the users to pay for the transaction costs. So which on Flow are like a fraction of a cent anyway, but you get the point. So you would have your your admin authorize the transaction, or if it's, for example, a case where the admin account needs to be one of the auth accounts in the transaction. So let's say you need to have another one here that's like the admin, and this is the auth account. Well, you can't do that normally in this scenario because there's only one authorizer here. There's only one signer, and that's the user, and you have no access to the admin's signer. So multi-sign is where you have multiple people really signing the transaction. So FCL.auths and then someone on your backend. Now, how the heck do you do that? Because you don't have access to the backend private keys and stuff like that. So that's what we're really going to be going over in this video, is how we can make it so that we can add the admin's signature. And one thing I will add is that what this is really helpful for, in my opinion, is cases where what we went over in the last video is that, remember, I was describing where you want to add public keys to an account because you can't run a bunch of transactions from one key ID. Well, in this case, because the person that's logged in through Blocto is the one proposing the transaction, you don't have that problem anymore, because of course each person that's logged in through Blocto on your client has a different public key, different key IDs, so you won't run into that problem with the sequence number. But you'll still have your admin authorizing and paying for the transaction. So that's the point of this video. All right. So with that out of the way, let's actually get into how the heck we would even do this. And let's go ahead, and I'm taking a peek at my notes here just so that I know I'm not doing this wrong. But let's go ahead and add a new file here. So it's actually right here already, but let me go ahead and delete all this because I don't want to spoil anything. So we're going to add a new file in here called server signer. And what this is going to do is this is going to send a request to our backend to have the backend sign on behalf of the admin for our transaction. Now, it's really confusing at first, but I promise you it won't be that bad. So what we're going to do here is we're going to make a new function. We're going to export it called authorization, or we're going to call it actually server authorization. Now, what this is going to do is this is going to be an async function that takes in an account, arrow function, and it's going to be like this. Now, what is an authorization function? Well, I went over this in my previous videos, but essentially this is an authorization function. So what we're going to define, what we're going to define in here is actually exactly what these are. these authorization functions. So we're pretty much redefining them, but we're going to do them in such a way that we can make a request to the backend to get the signer in the middle of it. And you'll see what I mean by that. So let's go ahead and return. And this is a lot like the authorization function you saw in the previous videos as well. So we're going to return account. And a lot of this, if you don't understand this, to be honest, I don't really either. So I wouldn't get too frazzled because this is sort of like confusing, but I'm just writing all this out so that you don't get tripped up. And we'll also fill some stuff in a second here. But we're going to put this as well, the key ID. So a lot of this is just a basic authorization function stuff that I've gone over in previous videos. So if you don't understand this stuff, I'd really recommend watching those two as well. Because then you'll fully understand what this is doing. FCL dot prefix. We're going to pass an ADR here, and we'll define ADR in a second. Key ID, which is a number. Key ID. And then we're going to have a signing function here. So this is the last thing that we'll need to return here. This is going to take an assignable, and this gets run. This signing function gets run when it's actually when the flow, like, you know, backend or blockchain calls these functions when you actually submit this transaction. And then in here, we're going to return another thing, which is basically just ADR, which is again FCL.with prefix, ADDR here. And then key ID. This is going to be a number. That is key ID again. And then the last thing here is signature. Cool. Now I think we have to also import FCL up top here, or else this isn't going to work. So let's go ahead and import FCL. Now, again, I know I've said this multiple times, but if you don't understand this, what this structure, you've never seen this structure before, watch the previous few videos and you'll totally understand it. Awesome. So, with that being said, we need a way to get this signature, because in previous videos, what we would have done is we would have had access to the private key. And so we would have defined a signature function, maybe up top here, right? We would have defined like a signature function that, like, you know, takes in, that has access to the private key and does a bunch of signing stuff with the private key. Now, let me show you actually on the back end what this looks like. It's this function right here, sign. And you'll notice that sign needs to have the private key here, or else you can't sign, obviously. Now, in this file on the front end, we obviously don't have the admin's private key. So we have to request the backend to give us this signature function for us. And then this will all work perfectly fine. So what we actually need to do, well, first of all, let's define what ADDR and key ID are. So ADDR and key ID here are your admins or your server's key ID and address. Now, what we're going to do for this video is we're going to hard code this, because theoretically you would know your admin's address and key ID. So you don't have to worry too much about it. And because in this scenario, we're not going to be using server authorization for the proposer, it's totally fine to use the same key ID. You won't run into problems. Because remember, you only have to alternate the key ID if it's for the proposer field. So let's go ahead and let's go to my backend and let's see what sort of account I'm using. I'm going to be using this account, which is this address. So this is going to be my server authorization. So I'm going to say const ADDR equals this, and I'm going to say the key ID equals 0. So very basic stuff. And I'll go over how we can sort of modify this at the end to make this a little more fancy, but let's just go with that for now. Now, the other thing we're going to need to add here is we're going to need to get this signature somehow. So before we actually return here, let's go ahead and say const signature equals await get signature signable. So this is going to basically call a function that we're going to define called getSignature that's going to make a post request to the backend to get the signature for us, passing in the signable message that we get through our signing function here. Cool. So let's go ahead and make a new function called const getSignature. This is going to be an async function that takes an assignable, and this is going to be an arrow function. And all we're going to do here is make a post request. So let's go ahead and say const response equals await fetch. This is just basic JavaScript API calls. So let's go ahead and pass in in my example, my API I'm going to define up here is going to be localhost 5000. That's where my server is going to be running. So let's go ahead and put in API here, and then we're going to do /sign. So that's the endpoint that we're going to call to make our post request. And then let's go ahead and do this, and let's define it's going to be a method, so it's going to be post. The headers, I'm going to go ahead and copy in these headers so I don't have to type this all out. And then the last thing we're gonna need here is the body. So the body is going to be a JSON dot stringify, and we're going to pass in the signable here as inside this object. So just like this. Now, once we get our response back, we're going to go ahead and say const signed equals await response.json. And I'm just typing this out for now so that we don't have to do this later. But I'm going to explain what this response holds, and we'll walk through every step of the way as well. And then let's say return signed.signature. Cool. So we're going to understand what this is returning in a second here once we actually make these calls. All right. So again, just to recap what we're doing, we're making, we're getting the signature from the backend because we don't have the access to the private key here, which we shouldn't, right? So this post request needs to be able to return to us the signature of the admin. So let's go ahead and let's close out our front end for now, and let's go back to our server. So let's go into main.js and let's make a new let me also get my notes up. We're gonna make a new endpoint here, app.post. App.post, and we're going to call this /sign, and this is going to be the request, the response, right? This is just normal stuff, and then we're going to let's just console.log and say hello, we're on the back end, so that we know that this is even working. And then what we're going to do is we're going to actually get, so we pass in the signable here inside our request body. So let's go ahead and get that signable back by saying const signable equals request.body. So this is just we're basically snagging the signable out of the request.body object, and then we're going to console.log signable, and that's all we're going to do for now. So let's do this. Okay. Actually, no, let's keep going here. Let's actually finish up this sign function, and then we should be able to see some cool stuff. So we have the signable on the back end, and so what we need to do is we need to have, right, because in a normal scenario, you would have a signature function here that passes in the signable, and you would sign it with your private key. Here, we're passing in the signable, and we need to sign it on the back end here. So how are we going to do that? Well, like I showed you inside this authorization.js file, we have this sign function and this hash function. Now the sign function theoretically has the private key here, right? So you wouldn't store it like this, obviously, because anyone could see that, but you would store it like a process, .env variable, in order to like keep it secure or whatever else you're storing it, your database, whatever it may be. But we have our basic sign and hash functions here, and if you don't understand these two, definitely go watch the previous videos as well. So I'm assuming that you have some sort of understanding of what these two are. Cool. And then we export this sign function, and we're going to call this sign function in our post request here. So we're going to say const the signature is what we're going to get back from signing this signable here. So sign, and we're going to do signable.message. And you'll see, we're going to see the console log of signable. But essentially what you would normally do is here, you would pass in the signable.message because you're signing the message. And so that's what we're going to sign. And remember, this signable.message is going to go to the sign function, which, signs the message right here. Cool. And then we're just going to return it. So res.json. And we're going to return the signature here. Awesome. And then once we return the signature here, remember, it's going to return to our server signer. It's going to go right here. So await response.json, which is going to be effectively the signature here. And then we're just going to return signed.signature, which is going to be the signature that is going to be replaced right here. So that's going to go into this variable, and we're going to put our signature there, right? And so I'm probably gonna draw out a diagram to help us sort of see this better. Yeah, so that's essentially what's going on. It's getting the signature and it's passing it right here. Now we're almost done. So what I'm gonna do is let me think what else I have to do here. Yeah, so let's go ahead and make a new function called multisign. So const multisign equals async. Pass this in, and the multisign, first we need to get the admin's authorization function. So this is going, let me close out some tabs here so this all makes a little bit more sense. But let's get the server authorization function first. So did we import this? No, let's import this together. So let's say import authorization function, or server authorization from server signer. Boom, love VS Code automatically did it for us. And let's, in the multisign, I keep thinking of multiverse when I say multisign. I love Spider-Man. But anyway, let's go ahead and let me look at my notes again. And let's in here say const let's actually go ahead and copy and paste what we have for the single sign, because it's going to be mostly the same stuff. The only difference here is that instead of the fcl.auths, we want our server or our admin to pay for it. So we're going to pass in the server authorization here instead. And same with authorizations, right? Why not? So let's just go ahead and do that. But our proposer is going to be the fcl.auth, so that's important to make that distinction. And then we'll log the transaction ID here. So let's go ahead and make a new button. It says run multi-sign transaction. So this is going to be called multi-sign. Cool. And this should work theoretically. So I hope that this is going to work well, and we can test it on our front end. So let's go ahead and refresh this page, and let's run multi-sign. So it's going to come up with a transaction here. We're going to approve, and then if all goes well, which I don't think it did. Okay, so it didn't. Oh, so it didn't go well because we're not running our server. So it made the request to our backend, but it couldn't get it because our server isn't running. So let me go ahead and run node main.js, which is going to spin up our server that's running at port 5000. And again, that's just this simple file right here. So main.js is going to run this file. So let's go ahead and try this again. And yeah, so run multi-sign. Comes up with this prompt, approve. And here we go. Here's our transaction ID. So let's go ahead and see if this works, and then we'll work backwards and see everything we just did and see if it makes any sense. So boom, it executed, and let's see if it works. Yay, so it's sealed. And look at this, right? So it's just the proposer and the payer are these two right here, and the authorizer is this one, right? So they're different. Now, yeah, so I knew that was messed up. For some reason, it didn't look right. But so the payer is OC603, and the authorizer is OC603. Now, if we go to our backend, that's exactly what we have, right? So that is our testnet account that's signing this transaction, right? So because we passed in, we're in our backend, that's the private key here. And it's using, it's using this account to do that. And then the proposer is 358cc, which is our person on the front end. So boom, we have multiple signers in this transaction process. But let's actually look at what's most interesting is let's go to main.js here, and let's look at this signable that we printed down here. So here's the signable. Now, you'll see it says, hello, we're on the back end. Here's the message that we signed, right? So this long thingy, the address, the key ID we're using. It even shows us this cadence here, which is the transaction code. All this cool stuff, the parameters, there's a bunch of information about the transaction. But the coolest part is that it also shows, who the payers and authorizers and all those people are. So it shows us that the payer is OC, the authorizer is OC, but the proposer is 358. So it tells us who the different roles are and all that kind of cool stuff. And so what's really going on, if we just take a step back and think about this, what's going on is that when this transaction runs, right? So it calls multi-sign, it runs this, it submits this transaction to the blockchain, and then in the backend somewhere, it's going into server authorization. Now let's just cover this one first. So fcl.auth is pretty easy, right? Because that's just implemented for us. But let's go look at server authorization and follow the workflow. So it's going to server authorization, it's passing in the account, and we hard-coded these two right now because these are just the admin address and the admin key ID so that we can fill in these simple fields here. And then when it runs the signing function to sign this transaction, it's making a call to the backend to get the signature of the admin, and then it's passing in that signature right here. So pretty straightforward stuff. Maybe not at first, but once you understand it, it'll definitely make more sense. Now, what I'm going to do is I'm going to leave it here for this video. But you may be wondering, well, Jacob, if I just set up a post request in my backend, then anyone can just get the server authorization, right? Anyone can just get the server signer, and that's not secure. Because if I want to run a transaction that takes 50,000 float token out of your account, I could just say, hey, admin, give me your signature and let me hack you. What we're going to go over in the next video is how you don't allow that, how you add checks on the backend to prevent against that. And we're also going to add a little extra spice to these hard-coded values so that we can ask the backend, hey, what address and what key ID do you want me to use? So that we're not hard-coding it. Because right now, we only have one account on the backend, so we know we're using these. But we can actually make another GET request to the backend that says, hey, backend, what account do you want me to use and what key ID, right? So yeah, that's all I have for this video. I hope this was helpful, and if it wasn't, please let me know. And just for the record, you can change these around if you want as well. Like we could use server authorization for proposer if we want For the payer, we could have the person on the front end paying. So it's really whatever you want. I mean, literally, if we switch these up and run another transaction, you'll see it'll work perfectly fine. But another cool part, by the way, is that this is also how you implement multiple authorizers. So if we make if we go back a little bit and we make this the server authorization, they're also, let's make the user the proposer, right? But let's pass in 2 authorizations here. So let's pass in fcl.auths and server authorization. So this is going to be the front end user, and this is going to be the backend admin, right? So now we have 2 people authorizing this transaction here. So I get a lot of questions about how to do that. This is exactly how you would do that. And so if we actually go to our web page here and we run multi-sign, let's refresh this page and let's run multi-sign transaction, and let's sign this transaction here and click approve, then it'll go through. And so here's our transaction ID. Oh, I shouldn't speak too soon. Let's make sure it actually did. But boom. So you can see that now there's, well, if I refresh the page again, you can see that there's multiple authorizers here. So there's, we can access multiple people's accounts. So yeah, that's all I have for this video. Hope this was helpful. And honestly, like, if you don't really understand what's going on, no one really does. I mean, it may seem like people, are really know what's going on, and it's confusing, and you may get, sort of down, but I wouldn't worry too much. I would just say that if you can sort of replicate this on your own and sort of understand a little bit what's going on, you'll be in a good spot, and we'll go over how to make this more protected in the next video. So thanks for watching, and I'll see you in the next one.